Right, so this is 1.4 network security in a nutshell, part A. And we'll be going through the 1.4.1 section of this part of the topic. So 1.4 is in network security, as I said. So 1.4.1 is directly looking at threats to a computer system and networks itself. So there are lots of different types of attacks that can happen to a network. Obviously, the minute you put computers on a network, you are reducing their secureness because you're allowing more points of access to that data. So that is one of the flaws of a network, but obviously you do get a lot of good things out of networking. But as I've got here, some extremely important systems like nuclear weapons and other things like that you just can't have hacked are often standalone, and they're not on a network to avoid any long-range threats at all. So therefore, to be attacked, there would have to be someone physically go to the system, which obviously is a lot easier to protect. So first of all, we're going to look at malware. Malware is a sort of overarching term for any malicious software that, software designed to damage a computer, steal stuff from you, or in any way just, not be what it's designed to do, what the user is expecting it to do. So one of them, viruses, is the one that you've probably heard of the most, is a form of malware. It is a malicious piece of software that's been created to cause damage or harm to a computer system. Okay. Now, the main thing with a virus, and I don't know if you know this, but just like a normal virus, a virus needs a host. So a virus actually attaches itself, computer virus, to an existing program or file. So it will infect one file or program, and then it will infect another one, another one, another one. So it spreads by infecting files and programs. Hopefully that file or program then be sent to someone else, and then that one will infect more and more. Okay, so look, there's about 82,000 viruses made a day for various reasons. So the main point here is that a virus needs a program or a file to attach itself to. Okay, so a worm, on the other hand, which is often mistaken with viruses, often get confused. It doesn't need another program or file to attach to. It can actually replicate itself. It itself is a thing. It can replicate itself, and it often achieves this over a computer network using vulnerabilities in the network security or something. So it will send itself throughout the system, okay, rather than a virus that actually infects different executable programs. So a virus can actually infect a program that you have. A worm doesn't do that. It just sends itself to the other computers, okay? Trojan horse is a famous story about ancient Greece where they had a gift that was a horse, and inside it they gave the gift, I can't remember who to, and they took the gift in thinking, oh, that's a lovely horse, and inside it was loads of soldiers, and then when they went to bed, the soldiers won the war or killed all the people there. So basically the whole idea of a Trojan horse is that it looks like something, but actually it's got a hidden agenda that you don't know about. So an example could be that you download a game, a bowling game. There was one a few years ago, a penguin bowling game that went around the internet, and that was a Trojan horse because whilst you were playing the game, it was logging your key presses and sending your password and username information to people. So it's a Trojan horse. So it pretends to be a normal program, but it's in fact designed to exploit your system. Okay. So they're the three types of malware that we're looking at in this course. Now we're going to look at social engineering, which is basically, a lot of people sort of see, a lot of experts, people are the weak point of security. So basically, people do silly things, stupid things, like writing passwords down and things like that. So basically, social engineering relies on human interaction. It's trying to trick people into ignoring security procedures to allow the person to access their data and money, etc. So phishing is one form of social engineering. I'm sure you've heard about it, where people send you emails trying to catch a bite, if you sort of mean. That's why it's called phishing. Catch a bite, catch someone, catch a fish on the hook with an email like this, pretending to be a customer, a bank, and sending it to a customer. You enter your bank details in, and they, of course, steal your money. common form of social engineering, which I'm sure you've heard about. So yeah, that's another one. Telephone phishing is another one. You get a lot of these automatic phone calls now pretending to be from a bank. Please type in your PIN. Please enter your password because your bank account's been frozen or whatever. But that's another type of phishing. So some are done by email, some are done by telephone. Okay, so that's the social engineering. That's all you've got to know about in this course is those sort of phishing and what social engineering is. So if you get to a system and you're trying to break into it and it's got a password. Now the thing with passwords is they are encrypted and it's very difficult to work back from an encryption. However, you can go forwards. So what I mean by that is one thing you can do is you can brute force attack it. And a brute force attack is a way of trying basically lots of different combinations of passwords and hoping that eventually you get the right one. Now, this can be done online, but often online, the website will stop you allowing lots of entries, or there'll be a delay between entries, and that's, killer. But this can often be done offline. If, for example, you can get access to the username and password file, even though it's encrypted, you have all the time in the world to break into that encrypted file. So basically, brute force allows you to try every single combination of letters and numbers to see if you can get in. Basically try until it succeeds. So you try A, B, all the different combinations. And that's another reason why it's better to have a longer worded password or use combinations of letters and numbers, because then it takes them longer to crack it. There is something called a dictionary attack, which is a form of brute force attack, where basically you use words from a dictionary first. Because often people will use words that are in the dictionary rather than random letters and numbers, and they can be cracked more quickly. I like to add, the course says complex passwords such as this are less likely to be cracked. Actually, nowadays, that would not be any more secure than password, really, because most people know that people will use at instead of a 0 instead of O, and things like these. These letters are not that much more intelligent. So what they'll do is they'll do the password, they'll try all the words, and then they'll try them with all the elite characters changed. So it says here this is much less likely to be cracked, but actually that's not true anymore. But that is what the course says. So I mean, it's not going to come up in the exam or anything. But just saying that using lots of numbers and symbols and letters make it more difficult to crack is true. Right, so that's brute force. Let's have a look at a DOS attack, a denial of service. So this is quite a simple attack where essentially you bombard a website or server with connection attempts. Imagine you're a plumber with a phone, and that's where you get your jobs, and someone wants to make your life hell. They could phone your phone constantly, thus stopping any real customers getting through to you. So you have essentially been denied of service. Now this is what happens with websites and servers. They can get bombarded, so the Play Store can go essentially down, Google could go down because they have lots of attacks of people trying to ask them questions. There are ways to block this and block certain areas, but it is quite tricky. Because how do you know the difference between a real request and a fake request? So basically another reason for DOS attacks can actually be to block another hack at the same time. So while you're taking down Netflix, you're secretly trying to steal their user data and passwords to steal their credit cards. So it can be quite a good idea to do that for the hacker, because your team will be focusing on, oh my god, Netflix is down, and not focusing on maybe something else going on. But yeah, you may have heard of a DDoS attack, which is the same thing really, but it's a distributed one. So basically you use a lot of different people to do it rather than doing it from one place. They normally make use of what's called a botnet, and essentially that is a net of computers over the internet normally that have been infected with malware and then are essentially triggered or used. They might be waiting for a code word or a time or whatever, or an instruction. But so maybe they're set to go off at 24th of March 2022 at 9 o'clock, and then suddenly all of those try to access Netflix at the same time. Everyone has got this virus or whatever, and then that takes down Netflix. And because it's distributed, it's harder to deal with. When it's not distributed, it's easier, because if it's coming from one place, one country, one area, one computer, you block that place. If it's coming from all over the country, it's difficult. So data interception and theft, not really rocket science. If you've got a network, then data travels in packets, which are small blocks of data. We'll talk about that another time. But essentially, a packet is a block of data. And, packets can be intercepted if they're going over a network wirelessly. I mean, they're out in the air. Like, you can take them. Yes, they can be encrypted, but, that's not always, impossible to decrypt or use other things. Sometimes they're not encrypted, and so, other things like that. So your data can be intercepted across networks. Obviously, wireless networks are more susceptible because, it's in the air. But it's also susceptible for WAN. So as data goes over the sort of larger, wide area networks, real serious criminals can sort of intercept it on the way. And obviously, data can be stolen because this is just, physically stolen, USBs, hard drives, etc. So all of the things have their own issues. If you don't use a network and you store it all locally on your hard drive, you get a computer stolen. If you do it on a network, it can be hacked. Yeah, so there's no certainty in any of it. It's just about trying to do the best security you can. So here I'm going to talk about SQL injection. So I'm going to come back to this slide in a minute because it's easier to describe by example. So hopefully you know that SQL is how you can search a database for answers. So let's say I wanted to log in to this system. So I've got a box on a website that says username. I've got a box on a website that says password. Okay. Now, when the person types in their username, let's just type it in. Steve11. Password is going to be soccer27, whatever. Now, I click login, and then some SQL will run, and then that will decide whether I've been able to log in or not. Now, one of the things that obviously that password needs to match the password. You'll see here the password is encrypted. This is called hashed. So the password's encrypted, and they would have to obviously do some decrypt script. But what I want is I want Steve's password. Let's say I don't know Steve's password. All right, boom. I want this hash. Now, I know it's going to be encrypted. You say, but it's encrypted. I go, yes. But if I can get access to the encrypted one, I can use a brute force method offline, spending, whatever, to try every single word. It's only one password. It won't take that long. And I will crack this this key eventually. So I'd say I know Steve's username because I've done something or I've got access to it. I'm trying maybe it's his email address. A lot of them are, which is a bit easy to get access to. And I want that. So let's just understand what happens when you try something. Let's just put, back in soccer or whatever. Doesn't really matter. So I click go. Let's assume there's a button that says, go. Right, I'll put, click search. So what's going to happen is, this is the sort of SQL that would run. This text box here and this would be given like a name. So I'm going to call them username _txt and password _txt. Right, so imagine these boxes on the website are called these. All right, so this is actually called username and password txt. They could just call them username and password, but they probably call them something else, right? So because that represents whatever they type in, right? So when you run an SQL, let's say I wanted to run an SQL, and this table is called TBL up for username and password. So if I want to get back the password, I go select password, because that's the name of the field, from TBL up, where username equals, and then this is the bit that you're searching for. So instead of writing Steve11, I'd put username _txt. Right? Because this is a website. So when I run this SQL query, whatever I've typed in there will get put in here. And then what will happen is it will return the password, and then I can check if the passwords match in another bit. But you don't have to worry too much about that now. All you've got to understand is when you type a username and password online, log in, it's doing some SQL script like this. Now the problem is, this is all text. So this is what SQL injection is. It's cheeky, right? So let's say I've at the moment got username equals username text. And what if I wanted to get back all the passwords, right? So but remember, all I can change is what's here, is here. Because this is the bit that I get to type into this box here. So when I run this would be put in. Steve11. Right? If I pressed go now, bang. And then it would say, get back the password or whatever. But what if I could edit this? Instead of what if I didn't write Steve11, but I wrote something like this, where username equals, I put the quotes in, Steve11, or true. What if I actually wrote that in the box? What would happen is, the SQL would read that, that would get put into here, and it would actually run this. That would be the SQL that gets run. And so now I'm getting the passwords for every user whose name is Steve, or if true. And true is always true. Or you can do something like, or 1 equals 1, right? So just 1 equals 1. Well, 1 does equal 1. So what it would do, it would go, right, can I get the password for that? And that would actually send back all the passwords. I could even select the username. So I get back the username and password. And so by editing the stuff you type in here, that you know is going to be executed in SQL script, then you can do what's called SQL injection. And it's called SQL injection because you're injecting some SQL commands into, say, a field on a website. It's nearly always on a website. So, you know, like, so for example, let's go on to a random, like ASOS or something like this, right? When you search for items on here, like hammer, okay, I don't know why I put hammer on ASOS, but hey, look, there's stuff come up. That is running an SQL query. It's saying select, you know, all the bits of star, probably all the data from table products where like hammer, where hammer's in there. So description like hammer, or name like hammer. So that the hammer's in the name, okay? And then it's returning all the pictures of anything that's got the word hammer in it. And that is just running an SQL query. Okay, when you log in, and that's where they basically do most of the hacks in the login bit, because this query will only be running on a table that's got items in it. But I mean, there is a possibility. You can even change the table, like you know, with other things. Like I could even finish, like if this was other stuff, and I could type in here, I could type other details here, and really change this up. You can do a lot of stuff with SQL injection, and it is quite hard to stop. So that's what SQL injection is, basically. So it's where an attacker can execute malicious SQL statements using software which controls a database management system. It normally affects websites that use SQL, and you know, nearly everyone does. So you know, it's quite tricky. How do you get around it? Well, there are certain things you can do. You can fix these searches up so that the computer treats this code as a string always, so that always becomes its own string, and then you can do it, and then you remove quotes before you run it. Use what's called sanitize the data, so you can make sure to remove any quotes like this. Put your own quotes in around the end, and then so even though you've written some code in there, it's treating it like a word, not code. There is other stuff you can do. Mostly it's to do with sanitizing the data, looking for OR 11. Fixing things, but yeah, it can be quite tricky because they're clever, they change stuff. But essentially what they can do is they can steal data using SQL injection. You don't need to know too much of it, you just need to know that they execute malicious SQL code on websites by adding codes to any text box where they're searching in. That, you know, you could do like hammer, you know, I'm sure they've already fixed it, but I could do hammer, end the quote, or 1 equals 1. And then they'll probably obviously have some clever not doing that. Here you go, look at that. You see, it has referenced that I've attempted to do some sort of SQL gibberish and done access denied. So ASOS, obviously, well done to you. But there are clever things. You think, oh, they've stopped it, but there's loads of cool things you can do. You can write that in ASCII. Have they cleverly tricked it in ASCII? You can do like the OR, like that pipe. Sorry, which is, oh, I can't find pipe on my keyboard. Pipe. There we go. That's another way of saying OR. That might come up. Yeah, you see. So then maybe you can go hammer, or 1 equals 1 and things like that. No, it's clucks me again. But I mean, obviously they're well done. But there's lots of higher level SQL injection that gets done out there, and don't think that just fixing it quickly solves a problem. You know, it is a problem. But there you go. So that's SQL injection. And yeah, that's the basics of part 1. Oh, just what is needed to run it? Just you need to have a database that it's run on. So any website that has a user database, you know, items, anything searching, anytime you're searching or logging in, basically. But yeah, that's it.